Okay, another common example that your school will ask you to count to explain a redox reaction is your oxidation state and oxidation number. Okay, so there are certain rules that we have to follow for your oxidation state and oxidation number. Right, in the previous video, I tell you that it is equivalent to the charge. Okay, but it is not always the case. So these are some of the rules that we have to follow. So any uncombined element by itself is given oxidation number 0. So element that exists by itself, right? This is uncombined copper. This is element by itself, chlorine. The oxidation state of both are 0 because they are uncombined and they are neutral. Okay, ions of single element are given the oxidation state equals to the charge, right? So in just now the example, like Na plus, you know, the oxidation state of sodium is +1. Cl minus, if they are uncombined, the oxidation state of chloride will be -1. Okay, group 1 elements will always have +1 charge. Group 2 will always be +2. Group 3 will always be +3 if they are metals. Group 7 will always be -1. Okay, so all these elements will have their charge from group 1, group 2, group 3 metals, and group 7 non-metals. Okay, oxidation state of more than one element chemically combined, meaning to say now you have a compound. Okay, now you will have a compound, and this one will equal to the overall charge of the particle. Okay, so example, ammonia is NH3. Okay, so this molecule over here, you have to know the oxidation state of hydrogen is always +1 because H tends to form H+. Okay, so in this case, I'm going to count the oxidation state of nitrogen. So I let this one be X. Okay, so in this compound where there's 1 nitrogen and 3 hydrogen, it will be X plus 3 times of +1 equals to 0. Okay, so X is the oxidation state of nitrogen. 3 times of +1 is the oxidation state of hydrogen. Okay, and because there's 3 hydrogen in the compound, it's 3 times of +1. This one will give you 0. Why 0? Because it's a covalent compound, the overall charge, there's no charge, so it's 0. So in this case, my X is equals to -3. So nitrogen oxidation state, okay, nitrogen oxidation state is -3 in NH3. Okay, in methane, CH4, for example, so using the same idea, hydrogen is always +1. C is what I am trying to count now, X. So X plus 4 times of +1 is giving me 0 because the whole thing, CH4, is neutral. So X equals to -4. Okay, same idea, how I was explaining it is carbon's oxidation state is -4 in CH4. Okay, let's try the nitrate ion. So NO3 minus. Okay, oxygen's oxidation state is always -2 because O form 2 minus oxide, right? 2, 6 for your oxygen. So it will gain 2 electrons to form O2 minus. So the oxidation state of oxygen is always -2. N is what I am trying to find. Okay, so X plus 3 times of -2 is going to give you, in this case, it's not 0, but the overall compound has a charge of -1. So X is equals to -6 minus 1 plus 5. Right, I have minus 6 over here. Bring it over to this side, you have plus 5. So this is plus 5. Okay, so in this case, how will I explain it out? It will be nitrogen, the element is nitrogen. Nitrogen's oxidation state is plus 5 in NO3 minus. Okay, so based on this idea, when hydrogen's oxidation state, right, it is always plus 1. So hydrogen is always given plus 1 unless your compound is a metal hydride. Okay, so what's an example of metal hydride is over here. For example, my sodium hydride, right? So sodium is always plus 1. So this time I have to count hydrogen X. And after you use the same method, plus 1 plus X equals to 0. X will be equals to minus 1. Okay. Oxygen has the oxidation state of minus 2 as explained over here just now. It's always minus 2 unless it's in a peroxide H2O2. Okay, so H will always be plus 1. So 2 times of plus 1. And I am going to try to count O now because this is a peroxide. So plus 2X is equals to 0. So if you manipulate it out, X is equals to minus 1. So in H2O2, the oxidation state of oxygen is minus 1 and not minus 2. Okay, so as a rule of thumb, right, we count oxidation states of elements of the compounds of your non-metal. Most of the time is carbon, nitrogen, sulfur, phosphorus. All the non-metals except your group 7, because group 7 is going to be minus 1. Okay, the rest of your non-metals, you have to count them. Okay, or you count the transition metals. Okay, transition metals have variable oxidation state. So sometimes your copper can form Cu+, Cu2+. So we have to check when is it Cu+, when is it Cu2+. Example, your iron, sometimes it can be Fe2+, sometimes it can be Fe3+. So we have to go and count when is it Fe2+, Fe3+. Okay, so we have to count the oxidation state of these elements. Is very, very important. Please remember that.